Right, good afternoon, everybody. Thanks, Graham. So, presentation I've got, it's a bit of a bias towards London and some of the work that we've been doing for planning sustainable drainage and some of the recent work we've been doing on retrofit as well. I'll move on to the next slide, which, so this work started about 3 or 4 years ago now, when the Mayor's Office were looking at the London Sustainable Drainage Action Plan. We were working quite closely with them at the time through Drain London and some of the other organisations. And there was a real need to, I think, set the scene, set the context with which we need to start thinking seriously about sustainable drainage across London. So we spent quite a bit of time building a model of London, and we did this by essentially sort of stitching together 8 sewage treatment works, hydraulic models that make up the 33 London boroughs, and then applying, as we've heard for some of the earlier presentations today, sort of urban creep. We did quite a bit of work on that about 5 years ago. Population growth, and then various sort of climate change scenarios as well. What we were trying to do really was to take the results and put it into a format, I suppose, that was sort of very visual, instantly recognisable, so that we could really start a debate around the challenges that London faces. Now, the process, the actual calculation that we've done is actually dimensionless. What we're showing there is the red areas are where in a 1 in 2 year event the network's essentially full, so all the pipes are running full, and then you've got various degrees of that down to green. So what it's not showing is areas where you've got significant flooding happening, but it was a good way of starting to start a conversation with planning authorities, lead local flood authorities, about challenges in their respective areas. So what you can see on the left-hand side, in this area around here, Hammersmith and Fulham, we've known we've had a long-standing issue with sewer flooding in that area, so we weren't surprised to see that. Likewise, further to the north up here, in the Brent area, we've got some studies in that area, and also to the east along the Lee Valley. But what this model was allowing us to do basically was to start to project forward in time what happens with urban creep, assuming urban creep goes unchecked. So we've seen in London loss of front gardens, parking spaces, and so on, more and more surface water runoff into the combined sewage network, which predominantly serves central London. And we start to see the problems becoming in those sort of low-lying areas more acute. And we've taken these projections right up to sort of 2050 and then up to 2080 as well. So what it's showing is that if we do nothing, we're going to see we're really going to start to have problems in some of these areas. So it really starts to, with some of the big London opportunity areas that are under discussion at the moment, which happen to be in some of the red areas. So Old Oak Common, for instance, which is sort of around Wormwood Scrubs, is around about there, which is in one of our most drainage stressed areas. So we were able to start having, just for a simple visualization, and working with the Mayor's Mayoral Development Corporation that's working on that, we're able to put sort of drainage requirements right on the beginning of the sort of planning agenda for that, and to start to think about how we're going to deal with surface water and the impacts on the local sewage network right at the beginning of the planning process. So that's been really helpful so far. And then there's also a lot of a number of London opportunity areas that are planned along the Lee corridor, so there's further conversation to be had. So that was a good start, and has been really, really helpful. Started a number of conversations and really sort of put the drainage issues on the map. I mentioned Countess Creek, which I've presented about before. Many might be familiar with the scheme. So this is essentially it's a lost river of London, Hammersmith and Fulham, Kensington and Chelsea, where over the last 10 years or so, around about 1,700 properties with basements have experienced sewer flooding. So the basement's very close to the sewer line. It doesn't take that much before the network begins to surcharge and back up into some of these older properties into their homes. And we've been working on a solution to resolve or alleviate the risk of flooding in this area for a number of years now. And there are 4 main elements to the programme. So we've got what we call flooding local improvement projects, which are essentially like a small package pumping station which cuts the property from the sewage network. We've got a new storm relief sewer, improvements to some of the local sewers, but we've also been, throughout the whole process, we were pushing sustainable drainage as much as we could. I think we would have liked to have seen SUDS play perhaps more of a role in the upfront reduction in the risk of sewer flooding. But I think what we recognise now is that going back to those heat maps I've just shown, that in order to offset the risk of climate change, urban creep and so on, we've got to consider, particularly in this catchment, which is highly urbanised, we've got to consider a retrofit programme as well. So around about 3 years ago now, we started work on a pilot, and I think this pilot for us was there are a number of obviously example projects that various companies up and down England and Wales have carried out to deliver sort of sustainable drainage schemes over the last sort of 5-6 years ago. What we're trying to do here, though, is really sort of try and measure the impact in very, very highly urbanised areas. So the 3 streets that we've picked are typical of the Countess Creek catchment of Hammersmith and Fulham and Kensington and Chelsea, but they present particular challenges when trying to deal with surface water runoff more sustainably. So with the 3 streets there, you can see there's no local water courses. The sewage network is essentially it takes all of the surface water into the combined sewage network in this area. Arundel Gardens there is very, very urbanised. There's a few sort of little trees trying to grow along the street there, and likewise Mendora Road. But what we're doing with these 3 streets, they are representative of the area. We've been monitoring them for, we've had loggers in for about 3 years, and have been developing hydraulic models to be able to replicate the rainfall events that we've been seeing. But we've also had loggers installed along control streets as well, next door to each of these 3 streets. So the idea being, what we want to do is to essentially maximise as much as we can do along the 3 streets, and then hopefully measure when we get a future rainfall event, the benefit and the reduction in surface water runoff, to help then inform how much of this type of approach we need to do to offset the impacts of climate change, urban creep going forward. So measurement has been quite a key part of this, and what seemed like a fairly easy exercise at the beginning rapidly became more and more complex, because the risk is that we could spend a lot of time and effort and money installing SUDS measures on these streets, only then in the future to record a reduction in surface water runoff, which is still within the noise and error banding of the loggers themselves. So we've spent a lot of time looking at technology, different types of loggers on the market, in order to be able to satisfy ourselves, I suppose, that when we complete the measures on site, we'll be able to see a statistically robust reduction in surface water runoff. So we've been doing these stringent calibration checks. We're looking at also putting loggers onto the individual SUDS measures using fairly new flow measurement devices, microwave devices that can measure very, very low flows. So a lot of thought went into that. We're not planning on doing this on all of our SUDS projects, but for this one in particular, this was one of the key things that, the key outcome that we wanted to get from it. So I have actually got some pictures of the things under construction. As we speak today, they are being constructed. It took a long time to get to this whilst we were going through the various machinations about whether we could measure the reduction in surface water runoff. But so as we speak today, along Mendora Road there on the left-hand side, where the entire street we're going for a mix of permeable paving with a kind of egg box geocellular system below it on one side of the street, and we're using aggregate on the other side of the street with permeable paving blocks over the top of it. And also along the streets, a number of customers have been offered and have taken up water butts as well. And on the right-hand side is Molina Road, so it's a similar setup there. We've got geocellular storage and a number of rain gardens which feed into this along the street. And that one's actually, that photograph on the right-hand side was taken a couple of months ago. So if you were to go along Molina Road now, you'll see a completed installation along the street. And what we're working on doing is working with some of the local communities there in planting out some of the rain gardens, getting them involved. Both the way we've worked in partnership with the London Borough of Hammersmith and Fulham on these two projects so far. In fact, we went as far as using their own contractor. It seemed more sensible to do that. They have more experience of working in the streets of Hammersmith and Fulham, so there was close cooperation between our own design team, design engineers, and then passing over to the highways team for Hammersmith and Fulham. And by and large, it's worked very well. There are very few complaints from residents along the streets. And now we're working with the parks departments as well, looking at the ongoing sort of operation and maintenance. Key thing, again, as with all of these projects, was getting community sort of buy-in to it. One of the things we're very keen to see, obviously we've got rain gardens being planted and so on, is getting buy-in from residents along the streets, local communities, to ensure that they're maintained going forward. So that's the SUDS pilot. So as I mentioned, that we're really sort of testing the measurement of that to measure the reduction in surface water runoff. We haven't got any results yet, but we'll start to see, hopefully in the not too distant future, we'll start to get some results out which we're quite happy to share. I think it'd be quite interesting to see once those three streets are completed, how much surface water runoff we can actually reduce in future rainfall events compared to some of those control streets. We do have an ODI, as Jonathan was talking about earlier on. So we have our what we call our 20 for 20 program, and we thought long and hard about, well, we've got to start doing more on sustainable drainage. What's the easiest way of really incentivizing the take-up? We felt we needed a very simple measure, so we ran with basically a target of removing 20 hectares of contributing area from from combined sewage networks. We focused on combined sewage networks in particular. We can go up to 50 hectares, but we've set ourselves an initial target of 20. And it's a very simple measure, but similar to Jonathan's experiences at Anglian, it's led to a whole range of new conversations that have now started, new ways of thinking with lead local flood authorities in the area, and lots of new thinking, new schemes, new ways of working starting to emerge out of it. So by just considering area up front, we can quite quickly appraise whether when we're talking to a lead local flood authority, whether it's an attractive solution, something that we want to get involved in, we can appraise it quite quickly. We haven't got to deal with, as we were in AMP5, having to demonstrate properties have been alleviated from the risk of sewer flooding as a result of the investment. Lots of partnership working starting, so with various different lead local flood authorities, also with other not-for-profit organisations. So companies like Groundworks, we're doing some work with Sustrans as well. Very, very good on the ground, dealing with local communities, getting them involved, getting them interested. The scheme on the left then was one we actually completed it towards the end of about 2009-10, which is the Herne Hill scheme. The ones that we're currently looking at the moment, we've got a very big scheme in so the Battersea Nine Elms regeneration area. This we came quite late to the table, I think, in terms of the planning process with this, but now there's a very large scheme there which will essentially connect up a lot of the sustainable drainage that has been incorporated through the planning process, but then maximising that and diverting it, taking it completely away from all the combined sewers and putting it into the Thames where it belongs. So that's a very big project. There are a couple of others then around other parts of London, Tooting Bec, where we've got a project there to essentially divert surface water to Tooting Bec Common and store it and attenuate it there. And similarly, we're doing some work with Groundworks and the London Borough of Hammersmith and Fulham again, potentially looking at Cheeseman's Terrace in Fulham. And there are other schemes that we're starting to look at. I've picked one that's outside London there, one with Swindon Town Football Club that's under consideration. So all of these are retrofit schemes. I think I would echo very much what Jonathan was saying earlier on, is that by having the freedom, I think, to think more creatively about incentives and design and so on. At the last price review, there are a number of things now that are happening that are different ways of thinking, different ways of working, and hopefully some very good schemes coming through. I think that's all I've got to say on this one at the moment. I'd be happy to take some questions.
Thank you. Questions? Ray?
Roy Tyndall, Just Base, which is based at UCL. We've heard a lot about drainage, but London is a water scarce area. How much of a problem is the densification of London proving, or likely to prove, both in terms of SUDs and in drinking water?
There are a number of things that we're looking at currently, which are around rainfall harvesting and combining that with flood risk, flood reduction as well. I think it's in its, if I'm honest, I think it's in its very, very early stages. We've been focusing, I think, at the moment on getting sustainable drainage right. Certainly for the large London opportunity areas, we've been producing what we call an integrated water management strategy, which addresses exactly those concerns. So we're not doing it on a retrofit scale yet to a large extent, but some of the big, some of the larger sort of areas such as Old Oak Common, as I've already mentioned, Barking, Riverside, the Meridian, which is further up in northeast London. Certainly integrating water supply with managing flood risk, more surface water more sustainably, is certainly on the very much on the agenda. And I think, you know, as those opportunity areas develop, we'll start to see a more integrated approach coming through. I think there's probably more to do on the retrofit side on that front.
Any more?
A couple of things. You emphasise urban creep a number of times, and then you said 2080, and I've not heard of any of the water companies projecting urban creep to 2080. Can you confirm that that's what you were doing? But more on the SUD side of things, the depth of construction. I was noticing the geocellular one was sort of at least 1 metre deep, and retrofit on roads and so on usually is constrained by infrastructure and so on. So I was just wondering what problems you had in there. And also, it looked as if you lined the geocellular one. Was it necessary? Because obviously losses from permeable pavement type constructions can be quite significant even for clay environments.
Sure. So first question, yes, we did go up to 2080. The urban creep was assumed to be linear. Now, whether that's right or wrong, but to be honest, by far the strongest or the largest influences on climate change. So we did have the UKCP 09 climate change scenario. So we did a lot of work with, I think, Atkins and the weather generator, and we were using the various climate change projections which are available up to 2080. But I take your point about urban creep. We did do quite a bit of work with a data set called Landbase, and what we did was to take that data and to statistically sort of extrapolate it. So we were looking at types of properties and so on across our area based on about 15 catchments, I think, that we used with land-based data. So there was some good data to begin with, but then to cover the whole of the Thames region, which we've done, obviously then you're limited to statistics. So yes, I think it's a fair challenge. But it's something that obviously we need, I think, to have a view on and an understanding. Getting back to the actual SUDs, so I think it was Mendora Road, there were significant challenges with services, as you can imagine. I wasn't involved in the design. I have been out to site to go and see the site team. They were stressing the importance of having very, very accurate topo surveys. We were finding gas mains that were in different places and so on, that we weren't expecting to see. And we did have to tailor the sort of depth and the location and some of the geocellular storage as we were going through to deal with things like comms pipes and so on. But by and large, they seem to have worked their way through that, as far as I can see. Then your final question was about lining, I think. I think I'm correct in saying where we've used, again, this is a pilot, so we're trying different things out, I suppose, to see what works and what doesn't. But because we're dealing with a combined sewage network, and it would be a dilute sewage filling up the geocellular storage and eventually trickling back out to so there's a control point back into the combined sewers. We did elect to line. There are a number of basements in those areas, so I think there was a risk of, or perceived risk of, perhaps contamination of the ground over time. So we have to be very careful about that. On Arundel Road, for example, which is the one we haven't started yet, some of the basements actually go out into the street and under the pavement. So there was quite a bit of concern about having water attenuated below ground so close to the basement. So we have lined there. We've tried geocellular storage down to a depth, which I'm assured, and even Hammersmith and Fulham Highways engineers assure me will take HGV loading and the likes of Ocado pulling in and all those sort of things. But it was good to have them bought into that. So that gives us a void space of about 95%, I think. We've also used aggregate as well, just to see the difference in performance on one side of the street as well.